Hello class. Yesterday we started the new topic of integration. Today we're going to continue on with antiderivatives. So yesterday the notes we took was basically just showing you the symbols and the notation for integration, and that basically at its most basic level integration is just reversing a derivative. And a lot of times you're given the derivative and you'll use integration to find out what the original function was. So that's what we call antiderivatives. Okay, so I'm going to go through a couple examples of these today, and then you'll have some to do for an assignment. Okay, so basically it will be find f of x, so find the original function given these derivatives. Okay, so let's go through these. Alright, so dy dx for x cubed. So I want to take the integration of x cubed with respect to x. Okay, there's nothing I need to rewrite in a different way, so I'm good now. So I can just go ahead and take the integration. So remember to integrate, you take the exponent and you add 1. Okay, and then whatever that gives us, obviously that's 4. So that's basically the number that we use to find integration. So we divide, whatever this expression is, we divide it by 4. And then we just write the new exponent. Okay, so I didn't go over this yesterday because I knew I was going to do some examples today, so I wanted to show you. So anytime you take the derivative, anytime you take the integration, whatever answer you get, you will always add a plus c. Okay, the c means constant. Okay, and it's just a constant. So why do we have to add that? So what is the derivative of a constant? So like here, if I took the derivative of 4, what is the derivative of 4? It's 0. What's the derivative of 400? It's still 0. So the derivative of a constant is always 0. So because this is the derivative, and because the derivative of a constant is always 0, this could be x cubed plus 0. So you don't really write plus 0, you just leave it as nothing. But because the original function may have had a constant, we have to account for that. Because remember, we're trying to find out what the original function was. So there was some constant here, whatever it was. And if I take the derivative of this, I'll get this. But you have to account for the fact that there was a constant. In these cases, we don't know what the constant was. Later on, we'll get into ways to find out what the constant was. But for now, whenever you take the integration of something and you're just trying to find the antiderivative, just add on a plus c to account for the fact that there was a constant. Okay, let's look at the next one. So I need to rewrite this using exponents. So I'm going to rewrite it as x to the x to the 1/2. So remember, square root means to the 1/2, and then that I can simplify. So that's x to the 1 times x to the 1/2. When you're multiplying variables with exponents, you add the exponents. So basically this simplifies to x to the 3/2. 1 plus 1/2 is 3/2. So I'm taking the integration of x to 3/2. Okay, so I'm going to add 1 to the exponent, and 3/2 plus 2/2, same thing as 1, is 5/2. So you always divide by that number, and then I write it with the new exponent. Okay, and I add on my plus c. Now let's clean this up a little bit. So I got a number, or I got a term over a fraction. So term over a fraction is this thing, if everybody remembers that. So I get 2 x to the 5/2 over 5, and then my plus c. Okay? And let's look at the last problem here. So remember, if you have multiple expressions, just like if you were doing the derivative, you take the derivative of each one separately. Same thing for integration. You just integrate each one separately. So it's basically the same thing as doing 3 separate integrations almost. Okay? So basically I just do this one, put in my minus, do this one, plus whatever the integration of that is. Okay, so let's do this one first. So exponent's 3, I add 1. Gives me 4. I divide by 4, so 4 divided by 4 is 1. And just get x to the 4th. Now I'm not going to put plus c yet. I'll do that at the very end. Once I do all of them, I'll just put a plus c that accounts for all of them. Okay, minus. Now I have to rewrite this using an exponent. Okay. So I'll do this x to the negative 2. So I have 2x to the negative 2. Now I'm going to add 1. So negative 2 plus 1 is negative 1. So that negative 1, I divide by that negative 1. So I have negative 2 divided by negative 1. That gives me a positive 2. And then my x with the new exponent. Okay. Plus, okay, what's the exponent here? Where there is no exponent. So it's like 4x to the 0 basically. So if I add 1, 0 plus 1 is 1. And then 4 divided by 1 is still 4. And then x to the 1. Or just x. Now I add my plus c. Okay, so that's the final answer. Okay, so hopefully those weren't too difficult. Hopefully you were able to follow along. And if you have any questions though, just message me on Teams and I can go through them. Your assignment is here. So 2 questions very similar to what we just did. So you can use the examples I did as kind of like I follow along while you work through these. And this one is very similar to, but you just kind of clean this up first and then you can work through that. Okay. Have a good day. If you have questions, don't forget to message me on Teams. Thanks guys.